Hi, this is part 2 of video 10, and in this video I will be continuing our journey through the RF Concrete Members add-on module. More specifically, I will be diving into the results produced after you fill out the input data and hit calculate. So let's get started. The first thing I will do is open up the RF Concrete Members add-on module, which you can find in the project navigator over here on the left, or we can access them in the drop-down list in the toolbar at the top. Next, since we already entered all of the input data in the first part, we can proceed with calculating our reinforcement. Now all this calculation is doing is pulling the internal forces from RFEM into the add-on module and applying the ACI equations to give us our actual reinforcement layout details for each member. You can also see it solves pretty quickly. So now you can see our results are presented to us in table format. You can see the required reinforcement is given to us first. Instead of looking at this by cross-section, we can also look at this per member. Like I mentioned in the previous video, you can see the tables are synced up in the background with RFEM. So you can see where we are in the structure when selecting our members. The first member we will take a look at is our beam member, member number 1. You can see we show you the required reinforcement for the top, bottom, and shear. All those details can be found down below in the table here. In general, the required reinforcement is handy to know, but what might be a lot more meaningful is what rebar size did the program lay out for these particular members. For this information, we can move on to the provided reinforcement tables and view what reinforcement the program is providing for those same members. You can see reinforcement is separated by a longitudinal, shear reinforcement, and then the location. We can zoom in and see the longitudinal reinforcement at the top of our beam in this graphic down here. And then we can also view the surrounding longitudinal reinforcement for our columns along with tie and shear reinforcement. Here you can see the provided stirrups for our column is 21 number 4 bars at 1/2 foot spacing on center. With these 3D drawings, you have the ability to double-click on them and get a full screen rendering on the longitudinal bars and ties. With this 3D rendering, you have the option to make changes to your reinforcement without having to go back to your input data. This can be done by double-clicking on the callouts for either the longitudinal or shear reinforcement. Here you can change bar size along with spacing. So for example, if I wanted to increase these bars to number 5, increase the spacing to 0.6, I can do that. Then you will see in the picture, this will change. And then when I go back into the tables, the program will recognize this and ask me to recalculate based on the ACI standard. Now you will see this reflected in the tables. Lastly, you can see we can check our serviceability checks down here on the left-hand side. If you watched part 1, you should remember that we are checking for deflection, spacing, and crack width. So altogether, we are getting a design ratio here for our different cross-sections and members. You can see down here that I changed the crack width, for example, for member number 3 to 0.004. You can see that the existing value is 0.007, so we are over, which this capacity ratio will tell you. You can see also down here in this message, crack width is greater than crack width limit. Another way to get another view of what's going on besides the tables is graphically back in RFEM. So we can click on the graphics button down at the bottom, and this will take us back into RFEM where we can view the results graphically. So you can see in the drop-down menu we are still technically in RF concrete members. Now we can select our beam member, and we can choose visibility by selected objects. Now over here on the left-hand side, we can display a diagram of the required reinforcement for the bottom. You can see that in the middle. Of our member, we need a higher amount of reinforcement because of the higher moment. And now we can do something pretty useful, which is down over here, we can overlay the provided reinforcement so we can visually see what the program has put into the beam member. This comes out to 2.36 inches squared of steel reinforcement. So this should always show that the provided reinforcement is greater than the required reinforcement, which you can see with this diagram here. Another benefit of viewing the results graphically is you can turn on the rendering of the ties and longitudinal reinforcement directly in the model. You can see the shear spacing zones as well. Any of this can be added also to the printout report. I can turn off my visibility, and now you can also see the reinforcement for our columns as well. Like I said, so any of this can be added to the printout report to see how the rebar reinforcement should be laid out. And so that concludes the results with the RF Concrete Members module and both parts on how to design concrete beams and columns in RFEM according to the ACI standard. If you have any questions, please leave a comment below or email us at our tech support email in the description below. We also have a lot of helpful FAQs and articles on our website.